The redshifted electromagnetic radiation, also called the cosmic background radiation, suggested to physicists that distant galaxies were moving away from each other at ever-increasing speeds. In view of this, there must have been a moment in the past when all the mass, which would result in the formation of these galaxies, would have been concentrated at the same point in space. Subsequently, this extremely dense and hot mass would have spread and expanded from the same moment in time in an event known as the Big Bang. Briefly, this would be the basis of inflationary theories. The universe to which they refer must expand forever, being condemned to chaos. In the images of the universe videos, we have highlighted the importance of our points of view. These include the point of view of physicists. When we look outside of ourselves, we are confronted with our own past, or things that have already happened. We cannot know what would be happening in our future, at least until the moment when the future flows into the thin plate of time, which we call the present. Although we occupy space on this plate, we cannot grip it tightly and prevent it from slipping away from us, moment by moment. When any theory is elaborated, our concern is to find subsidies to justify it. In the case of inflationary theories, unconditional support would have been given by cosmic radiation. It is often called background because it could only be followed in the direction of our past. The dependence of inflationary theories on light, synthesizing all forms of irradiation, constitutes a delicate point, the Achilles heel of these theories. This is because we have no other instrument to define space and its geometric changes other than light. Space doesn't have the power to communicate anything to us, at least not directly. This obliges us to wait for the late manifestation of events. One can easily see that science treats space and light as if they were one and the same. There is no way to treat the two separately. Inflationary theories are an example of this. They tell us that, after the Big Bang, space would have gone into continuous expansion. As space stretched, dragged the radiation with it. So, today, the light from most galaxies would be showing us a redshift. This happens when the wavelength stretches out, side by side with space. Consulting the bibliography that addresses the behavior of light and its harmonic movement, I extracted some counterpoints to inflationary theories. For example, in the book Physics 2 by Resnick and Halliday, in its 4th edition, it is noted that the harmonic movement of light, which is represented in the mass spring set, is a system of conservative forces. Whether in the spring stretching phase or in its contraction phase, the force always points in the opposite direction. In both phases, the spring is always tending towards its resting position. The movement is cyclic, and you already know it from the grandfather clock. On page 58 of the cited book, the authors include gravity in the list of conservative forces and analyze the behavior of elastic potential energy. The subject is very complex, including complicated formulas, so I will stick to some conclusions drawn from the book. To describe the action of gravity, Resnick and Halliday choose a configuration in which a particle and the Earth would be infinitely far apart. We, then, assign zero potential energy to the system. The zero potential energy configuration is also the zero force configuration. we make a similar choice in defining the zero-energy configuration of a spring as the configuration in which it is at its normal, unstretched length, in which case the restoring force is zero. Note that there is a coincidence between this model of gravity and that of the harmonic movement of light. In fact, there is no difference at all. Continuing, the authors tell us, we assume that the particle moves towards the Earth following the radial direction. The gravitational force acting on the particle has a negative sign indicating an attractive force. The negative sign indicates that the potential energy is negative at any finite distance. That is, the potential energy is zero at infinity and decreases with decreasing distances. For the viewer to better understand the importance of physics observations, the harmonic movement of light is also represented in a model in which we have a block connected by a spring to a fixed end. In its resting position, there are no forces acting. In Halliday's quote, this would happen when the particle is motionless at infinity. When the spring stretches, there would be an increase in potential energy. If we go back to the quote, it implies the idea that this spring stretch could not happen inside our observable dimension. Potential energy is zero at infinity and decays with decreasing distances. Thus, in space-time, the potential energy would always be decreasing and never increasing. Unless physics revises the concepts in this area, after the Big Bang, galaxies could not be following the expansion of space in the presence of continuous acceleration. Acceleration would only be possible when space was contracting, accompanied by a constant drop in potential energy. This would make any expansionary theory unfeasible. If space were expanding in real time, galaxies would tend to collapse over the starting point. Theorists have made attempts to circumvent the problem by suggesting the existence of dark energy, which overcomes gravity. According to the precepts of physics, to which there is only what can be measured, this hypothesis would not be acceptable because, until today, no one has been able to prove the existence of dark energy. As galaxies are always seen with a delay, which cannot be disputed, the acceleration can and should be real, while the expansionary movement should be fictitious and apparent. The problem with evaluating science is that it restricts itself to events that can be directly measured. This is not the case with expansion, as it would be evaluated indirectly through the use of light. If in the remote tracking process, we were mixing the behavior of space and radiation, resulting in the formation of a continuous whole, we could not neglect the behavior of light. The first phase of the harmonic motion of light predicts the stretching of the spring and an increase in potential energy. Extending the mass spring model to gravity, as suggested by Resnick and Halliday, the stretching of space would have to be the result of negative work, accompanied by an increase in potential energy. The expansion of space would have to be placing itself outside of space-time, because, inside it, the potential energy is always decreasing. Another alternative interpretation, though debatable, would be to say that the expansion of space is taking place in our future. This makes sense, because, if light from a star takes time to reach us on Earth, one might think that the expansion of space would be contracting time to subliminal levels. This complementarity between space and time is in accordance with the provisions of the theory of relativity. When space curved in our future, in the presence of increased potential energy, it would be transiently holding back light and the information it carries. In the case of the Big Bang, and according to inflationary theories, this retention would be around 13.7 billion years. Thus, when we use light as a study tool, we should not reason with physical distances in space, but with relative spacing and time.